Good evening. Welcome to the QCIS channel. On this channel, you get a daily dose of science, technology, engineering, and math. My name is Leon Jones, and tonight I'm going to do a short video on the certification that is basically in the manufacturing industry. And you have different types of certifications. You have Six Sigma, black belt, green belt. Now tonight, I'm just going to give you an overview on what is the Six Sigma certification. How did it become part of the certification for manufacturing? Let me just share my screen and we're going to go look at this PowerPoint. All right. Now, a lot of this information as we talk about Six Sigma, it comes from two areas, manufacturing, and I could also say industrial engineering. Now, the development of Six Sigma, here's what happened. Motorola, which Motorola used to make some good products. They make the Motorola Razr, but Motorola had one of the backpack cell phones. Well, Motorola launched the Six Sigma program back in the 1980s. And the first company to do that was General Electric. Now, they basically initiated their version of Six Sigma in the mid-1990s. So today, organizations in all industries have applied Six Sigma in recent years. Now, Six Sigma has replaced TQM and BPR as the key strategy for quality improvement. Now, TQM used to be total quality management. Total quality management. As I move on to my next slide here, definitions. Okay, you see that little sigma sign. That sigma sign is in statistics. That stands for standard deviation, which is a measure of variability. Now, Six Sigma is a quality improvement philosophy that focuses on eliminating defects through reduction of variation and a process. And then we have defect. It's a measurable outcome that is not within specification limits or acceptable limits. Now, we're going to do a comparison right now. We're going to compare TQM and Six Sigma. Now, if you look at TQM, TQM was basically a philosophy which dealt with the management of quality improvement, where Six Sigma focuses on cost reduction and defect reduction. Now, TQM also encourages the involvement of all employees, where Six Sigma relies on a selected group of highly trained employees. TQM, senior management provides all the direct support, whereas in Six Sigma, senior management is held accountable for all the results. Now, the key success factors for Six Sigma include committed relationship from top management. Then you have the integration with existing initiatives, business strategy, and performance measurement. There's also process thinking. And when it comes to discipline, you have to have market intelligence and discipline customers. Then you have training. Then you deal with the bottom line orientation and continuous reinforcement and rewards. Now, with everything, there are metrics. Now, as you see, what you're given in this PowerPoint, you're given the Six Sigma metrics measuring defect rate. Now, DPU, which is defects per units, that equals the number of defects. Then you have, I guess, defects discovered divided by the number of units produced. And defects per million opportunities, that's DPMO, equals the number of defects discovered divided by opportunities for error times a million. Now, generally, you see a lot of this if you go into industrial engineering. Now, some people say industrial engineering is not really engineering. Well, it is. Industrial engineering deals with a lot of optimization, deals with a lot of what we call waste, or it deals with Six Sigma. It deals with lean. In other words, the reduction of waste, cost reduction, cost effectiveness, linear programming, operations management. This is all part of Six Sigma and industrial engineering as well. Now, the estimating defect rate minus the CP, which is the process capability index. Well, of course, you have the upper and lower specification limit, which is known as USL, LSL. So the basic equations, CP, which again is your process capability index, equals the USL, which is the upper specification limit, minus LSL, which is the lower specification limit, divided by Six Sigma. So here's how you get everything. All right. Let's say you have the time to process a student loan application. Standard equals 26 working days. The specification limits go from 20 to 32 working days. Then your sigma equals 2 working days. So what are we trying to find? Your capability index. So you're going to plug all the numbers into this formula right here. 32 minus 20 divided by 6 times 2, that equals 1, or 3 sigma. Very easy equation. Again, if you're in industrial engineering or manufacturing engineering, you will see this equation. Then you have CP index and DPMO. Again, we're dealing with millions here. So here's all the information. CP index 1, DPMO is 2700. CP index 1.33, DPMO 63. And you have 1.5 for the CP index, 6.8 for the DPMO, 2 for the CP index, and 0.002 for the DPMO. This is all coming from the equations. Then again, you deal with the estimating process capability index from A sample minus CPK index. Now, X bar, when you see that X bar, it's all spelled out here. Where do you see X bar? X bar is usually a function in statistics. It's basically, you're taking the average. That's what X bar is. And the X bar is the average outcome from a sample, whereas S is the standard deviation from a sample. And if you plug all of the equations together, here's what you get. Get this formula right here. Now, put some numbers in. You have your X bar equals 25 days, S equals 3 days. CPK, which is your process capability index, or your minimum. You got 32 minus 25. And where did it get 25 from? I got the 25 Your 25 was your X bar. So when you're doing equations, make sure you pull out all of your given information. That's most important. And make sure your units are correct. Well, here we don't have to deal with units, but later on, we will have to deal with units. So you have all your given information and you just plug it in to your equation. And this is what you get now. This is doing it by hand. You can do it a lot faster with Excel. But that's how you get your CPK index. Again, this is getting a lot more into statistics, ensuring that the process variation is half the design tolerance, CP equals 2, while allowing the mean to shift as much as 1.5 in standard deviations. And here's what they're talking about right here. Here's the graph. Everything is shifted. It's almost like a cycle. You know, when you do a sine wave, everything is sinusoidal. You're shifting the amplitude. This is what that looks like. But this is what you're going to see if you go into the field of industrial engineering. And this is going to be on that Six Sigma test. Again, you have other certifications, green belt, black belt, project management. When you get into industrial engineering, you will focus a lot on management. And it's a good field. Some people criticize it, but there are a lot of statistics involved with industrial engineering, and there's also a lot of engineering economics. Let's move on. Okay, K Sigma quality levels. Six Sigma results in at most 3.4 defects per million opportunities. And this right here is what we call your quality levels. And each sigma in this chart is basically in multiples of 0.25, and you can see all the numbers changing. You have 3 sigma, 3.5. You have 2 sigma down here, but you can see all the numbers changing. And you're dealing with defects. This is known as your K Sigma quality levels. All right. GE, now this is definitely familiar. GE has a problem-solving approach, and I use the acronym DMAIC. What's DMAIC? It's define, measure, analyze, improve, and control. I took a class on statistical process control. Saw a lot of DMAIC. Well, we're going to break down and find out what DMAIC is. All right, DMAIC, define. You identify customers and their priorities. You also identify business objectives. Then you select a Six Sigma project team. Define CTQs, critical to quality. That's what CTQ is. And you look at characteristics that customers consider to have the most impact on quality. Then you have measure. First, you had define, I gave you. This is measure. So I'm breaking DMAIC down. When you measure, you determine how to measure the processes. And that's by identifying key internal processes that influence CTQs. Measure the defect rates currently generated relative to those processes. Analyze. You analyze something, you determine the most likely causes of defects by identifying the key factors that are most likely to create the process variation. Improve. When you improve something, you identify means to remove causes of the defects. And that's basically when you confirm the key variables and quantify the effects on CTQs. You also identify maximum acceptable ranges for the key variables and a system to measure deviations of the variable. And you also modify the process to stay within acceptable ranges. Control. This is when you determine how to maintain the improvement. And this is when you utilize the tools in place to ensure that the key variables remain within the constant acceptable ranges under the modified process. Now, tools for Six Sigma and quality improvement. Well, just as I mentioned, it relies heavily on statistics. So you have elementary and advanced statistics. Then you get into product design and reliability analysis. Again, product design and reliability analysis. Then you have measurement. Then you have process control and process improvement. Implementation and teamwork. Again, you have implementation and teamwork. Then you have lean thinking. It's like lean management. Then you have customer surveys and feedback. And organization for Six Sigma, Project Champions, which deals with project selection and management and sharing of knowledge. Then we get into the belts that I told you about. You have your Master Black Belt. Now, that is the highest belt you can get. And that's basically dealing with your technical leaders, instructors, and coaches. Then you have your black belts, project team leaders, and team members. Then your lower one, green belt, your project team members and temporary team members. So basically, if you ever go into the field of industrial engineering or manufacturing engineering, you're going to hear the word lean, you're going to hear the words statistical process control, you're going to hear the word DMAIC, you're going to hear the word Six Sigma, you're also going to hear the word black belt and green belt. Now, there's certifications, very difficult, but you can pass them. And the belts in the manufacturing industry, and this also comes from Toyota, they are highly regarded. Now, some areas that have a lot of manufacturing, the state of Michigan, especially when they made cars, had a lot of people that were Six Sigmas. A lot of them were master green belts. They were highly regarded in the industry that deals with manufacturing. In fact, a lot of your industrial engineering programs are in Michigan. You have some here in Indiana, but where you have areas that do a lot of manufacturing, you're going to have a lot of industrial engineers. Now, of course, the areas that can be very tricky when you deal with Six Sigma, that's the statistics. So you have to understand how to calculate the mean, mode, the median, standard deviation. You have to know what the charts say. You're going to have single variable charts. You're going to have double variable charts. And you also have to understand DMAIC as define, measurement, analysis, improve, and control. I remember that very well. Don't know what DMAIC is. DMAIC is an acronym that stands for define, measure, analyze or analysis, improvement, and control. You're going to see that all over the manufacturing industry. And it's very important that you understand that, because when you deal with product design, you get into quality. Now, back in the days, we had total quality management, and that was also used to empower employees. So when employees were empowered, they could actually make decisions. Found out that didn't work too much. So the Six Sigma was brought in. You're going to hear the word lean. You're optimizing waste. Lean manufacturing is the big one. I work in the construction field, so now there's lean construction. And you have to learn how to optimize waste to lower your costs. Remember, waste costs money. Let me give you an example. In a restaurant, your waste, reason why you don't make the money you should in a restaurant business is you have a lot of labor, you have a lot of food costs, and also you have other costs, like if you buy a set of dishes and you break them, silverware gets thrown away. So these are areas that could involve a little Six Sigma. But what you just heard was a overview of Six Sigma. Now, if you're interested in getting into Six Sigma, start looking into industrial engineering or industrial engineering technology. And industrial engineering is a good field. It's got a 10 to 13% I mean, that is great over the next 10 years. That's above the average, and they need people. Now, of course, the FE, when it comes to the industrial engineering field, is actually the results are lower than the civil FE, and you don't have as many people taking the industrial engineering FE. But it is difficult because you have more statistics, more engineering economics, you have linear programming, operations management, project management. It's a lot that you need to know on that exam. But get your FE and PE in industrial engineering and get your Six Sigma, you'll be golden at most organizations. So that concludes this topic on Six Sigma. If you like what I just presented, please comment, share, and subscribe. And also, you can check out my main channel, the 411 Talk Zone radio show, also on YouTube, because once I finish recording all of my videos from both channels, I then upload them to Twitter, which is now X. Now for the QCIS channel, I go one step further. Since it is an educational channel, you will also find the QCIS channel on my LinkedIn page. Now, also for my 411 Talk Zone radio show channel, just started posting some videos on Rumble and, of course, Truth Social, because we're getting into the political season, and the 411 Talk Zone radio show videos, they have to be on different platforms so I can get more people to get an understanding of what's going on with the presidential elections. But once again, thank you for listening and viewing this content for Six Sigma right here on the QCIS channel. Now, on the QCIS channel, get a daily dose of science, technology, engineering, and math. Till next time, my name is Leon Jones. I want you all to have a wonderful and gracious evening.